Hello, my dear student and learner. Today we are going to discuss about the stability of a carbocation or somewhat discussions about the carbocation. Carbocation is also known as a carbenium ion, but so many people are misinterpreting as a carbonium ion. There is difference between the carbonium ion and carbenium ions. So at the last part of this video, we discuss about what is carbonium ion and what is carbenium ion. Carbocation is a reaction intermediate. Before going to understand this video or a lecture or a stability of carbocation, you must have a clear the concept about inductive effect, hyperconjugation, aromaticity, anti-aromaticity and resonance. If this concept is not clear, don't go this video. Before see this video, then you get very clarifications about this concept. Let us go ahead. And what is this carbocation? So in case of basic informations, I want to tell you that basically in organic reactions what happen, we have a reactant. हमारे पास एक reactants होता है. That reactants reagent के साथ reactions in presence of solvent, it produce an intermediate. That intermediate is very important for us. Now from this intermediate, it is converted to either product or a byproduct. So what is that intermediate? Carbon containing plus charge, carbon containing minus charge, carbon containing free radical. This is known as a carbocation, this is known as a carboanion, this is known as a free radical. In today's lecture, I am more concentrate about this, a stability of a carbocation, because always we have to understand the stability of carbocation. So what is carbocation? Basically, if I draw here this one structure and that structure gives some idea, इसमें से हमको कुछ पता चल जाएगा. This is a basic carbocation. This is a basic carbocation containing plus charge. So here the characteristic is incomplete octet. This has 2 electron. This sigma bond has also 2 electron. This sigma bond has also a 2 electron. So there is a total 6 electron. So we can say, हम ऐसा बोल सकते हैं कि यहाँ पे octet complete नहीं है. Let us go ahead. 3 covalent bond. It is very easy to understand that there is a 3 covalent bond in case of a simple basic carbocation. One is this, second one is this, third one is. Let us go ahead. It has a positive charge. Simply it is known as a cation. So it is known as a positive charge. Then electron deficient or Lewis acids. Because if this octet is complete, then we can say it is satisfied. Octet is complete, then it is satisfied. It is less than octet, then electron deficient. It is electron deficient, or it required an electron to complete the stability. Now it had a 6 electron. To complete the 8 electron, it required a more electrons. और दूसरा ये बता जा रहा है कि this is a Lewis acids. We know that those who have a positive charge, they all are a Lewis acid. Let us go ahead. Now hybridization is a very important concept for us. This all are sp2 hybridizations. I have already explained about the concept of hybridizations. If you don't know this concept of hybridizations, it is better or my advice to clarify this concept of hybridizations. This all are a sp2 hybridizations. This is an sp hybridizations. This is also an sp hybridizations. It's a very simple, but most probably we are more concentrated about the sp2 hybridizations. Okay, चलते हैं आगे. Now when this carbocation will form, here I want to share with you basically the word come when your non-metal have a positive charge. Non-metal have positive charge, then basically we are applying the suffix "-um". So what is, when we have to use, suppose we have H3O plus, this is known as a hydronium. Then we have another one is uh, NO2 plus, nitronium. We have Cl plus, chloronium. Then we have carbon plus, this is known as a carbenium. Okay, so yum is used when your non-metal have a positive charge. Basically, carbocation when formed when we have a more electronegative elements. Regarding this electronegativity, I have already explained you in a inductive effect concept which are the electronegative element. Basically, I am writing here F, Cl, Br, I, OH, NH2. These all are a more electronegative compared to the carbon. When they do the reactions, जब इसमें reactions होगी, then what happens? This bond is going to be break. During the breaking the bond, it forms this carbocation plus charge. Those are more electronegative, they acquired a negative charge. So this is sp2 hybridizations. So whatever the black color indicate, they form, this will form a covalent bond, this will form a covalent bond, this is also make covalent bond, this is also make a covalent bond. Now this is an p orbital. So dear student, here a positive charge is acquired in a p orbital, and p orbital is responsible for formation of a resonance. Formation of a resonance. So this is a very basic hint about the carbonium ion and carbocation. Now my main goal is to explain the stability of carbocations. So dear student, for the carbocation, carboanion, free radical, and one more concept, that is carbenium ion. For all we have one technique, that is array high. So what is array high or what is AR high? AR high means this is a aromaticity. We have to first check it. This is aromaticity. Then we have a resonance. Then we have hyperconjugations. Then we have a inductive effect. Now I have told you, or if you have seen my video of resonance, then I told you CDOL. This is a same concept, array high. The first you must have to check aromaticity, then you check resonance, then you have to check hyperconjugations, then lastly you reach to the inductive effect. So here the stability of carbocation is plus I plus M or hyperconjugations. Normally, dear student, increase charge that decrease a stability. So to increase the stability, what we have to do? We have to decrease the charge. अगर हमको स्टेबिलिटी बढ़ाना है तो क्या करना पड़ेगा कि चार्ज डिक्रीज करना है. So now this has a positive charge. Carbocation has a positive charge. To satisfy this positive charge, we must have to give the electron via inductive effect, via mesomeric effect. So those group which gives the electron, they are plus I, plus M and hyperconjugations. So उसको क्या बताएंगे? Plus I. अगर हमको याद नहीं रहता, then what we will do? The plus charge is stabilized by plus effect. Simply a minus. In a next video we will see a carboanion. It is stabilized by minus I and minus M effect. तो हम ऐसा conclusion पे आ रहे हैं कि the plus charge is stabilized by plus I plus M and minus charge on carboanion is stabilized by negative charge. Negative is stabilized by minus I effect, positive is stabilized by plus I effect. I will give you this example also. But dear student, this sequence is very important. Array high. At the last, it is anti-aromaticity. That also I will explain to you. So let us go ahead. This is a stabilized by aromaticity. I have told you that. So if we will say here, this is a carbocation. The first requirement, yes, it is a carbocation because a carbon containing a positive charge. So we are happy, okay, it is carbocation. Now we have to see about whether it is stable or not. To get the stable, we have to find array high. So what is that array high? First we have to see whether it is stabilized by aromaticity. Then we check it is sp2, this is also sp2 and it containing 2 pi electron. So my dear student, it containing aromaticity, it is stabilized by aromaticity. So this is a stable carbocation. Let us go ahead. Stabilized by resonance. So here again we have to write array high. So here we discuss about, if we say here there are two structure, we have to come to the conclusion. हमें ये conclusion पे आना है कि कौन सा वाला structure बहुत ही stable है. So if I see here, then this is a double single plus and there is no. So I can say the aromaticity is not present in the both the case. I write here array high. Here also I write array high. Both the structure does not have aromaticity. Let us see. This structure has resonance. This structure has not resonance. So by default, I can come to the conclusion that it is stabilized by the resonance. So it is more stable. So the structure 1, it is a more stable carbocation. Let us go ahead. This is our structure. Again, we have to write array high. Array high. So in both the structure, there is not any concept of the aromaticity because aromaticity is not gained by what is aromaticity. That concept, please you understand from this video of aromaticity part 1 and part 2. It containing resonance, yes, it containing resonance. It containing resonance, yes, it also containing the resonance. Now the question is, which structure has more amount of the resonance? So this is stabilized by this resonance and it is also stabilized by this resonance also. It is only stabilized by only one type of resonance. So I can say that both the structure have resonance and the structure 1 has more amount of resonating structure. Increase a resonating structure, then increase stability. So by default, this is a more stable resonating structure. Let us go ahead. Again, we have to write array high. Again, we have to write array high. This is not at all a cyclic structure. So I can say that the structure is not stabilized by aromaticity. Structure is not stabilized by aromaticity. This structure has resonance. No, this structure has no resonance. This structure has resonance. Yes, this structure has resonance. So by default, who is going to be win? The structure second is going to be win because this is resonance, double, single, plus. If you don't know the concept of resonance, please, to get or improve your concept, see the video of resonance also. This is that have no resonance. उसके पास resonance नहीं है और ये resonance से stabilize नहीं हो रहा है. अगर resonance आ गया तो by default that will win. So here again I write array high. Here also array high. Here also array high. The structure 1 is not stabilized by aromaticity, structure 2 is not stabilized by aromaticity, structure 3 is not stabilized by the aromaticity. Structure 2 has resonance, yes, double, single, plus. It has also resonance, double, single, plus. It has also resonance, double, single, plus. All have a resonance. तो किसमें ज्यादा resonance है? So almost all the structure has a same resonance, double single plus, double single plus, double single plus. So we cannot come to the conclusion from the resonance, we have to go to the hyperconjugation. Whether it is stabilized by the hyperconjugation, no, it is not stabilized by the hyperconjugations. Yes, it has hyperconjugation, yes, it has hyperconjugations. तो मुझे कैसे पता चला कि इसमें hyperconjugations है? It should have a alpha sp3 carbon to the carbocation. It has also alpha sp3 carbon. Now ये तो last हो गया. This it gave the third number. Now among these two structure, which has more number of hyperconjugating structure? किसमें ज्यादा hyperconjugating structure है? तो हम इसमें देखेंगे कि कितने अल्फा हाइड्रोजन्स है. भाई इसमें 6 अल्फा हाइड्रोजन और इसमें 3 अल्फा हाइड्रोजन. So by default, which is going to be win? This is going to be win because in this case there is more amount of hyperconjugating structures. So this is acquired the first rank, this acquired the second rank, this acquired the third rank. सभी में resonance है, पर all the structure have same resonance. We have to go to the hyperconjugation. The third number structure, this one, those acquired the third number, it is not stabilized by the hyperconjugations. These two are stabilized the hyperconjugation. तो हमें इसमें दिखना पड़ेगा और we have to think about कि किसमें ज्यादा hyperconjugations है. तो resonance ज्यादा है वो कैसे पता चलता है? डबल सिंगल प्लस, डबल सिंगल माइनस और डबल सिंगल डॉट. हाइपरकंजुगेटिंग स्ट्रक्चर ज्यादा है वैसे कैसे पता चलेगा? तो जिसमें अल्फा हाइड्रोजन ज्यादा है. लेट अस गो अहेड. Stabilized by hyperconjugation or inductive effect. Suppose we have such a structure. So I draw the structure like this. This is CH3, this is CH3, this is CH3. This is plus. This is CH3, this is CH plus CH3. This is CH3, CH2 plus. This is only CH3 plus. Okay. चलो हम सभी में लिख देते हैं. अरे हाय, अरे हाय, अरे हाय, अरे हाय, AR हाय, ऐसा भी बोल सकते हैं हम. तो किसी में भी एरोमेटिसिटी नहीं है, देख लो, किसी में भी एरोमेटिसिटी नहीं है. None of the structure is stabilized by the resonance or does not containing the resonance. Now the hyperconjugations, इसमें hyperconjugations नहीं है, इसमें hyperconjugations नहीं है, इसमें है. That also containing hyperconjugation, that also containing the hyperconjugation. How can I know that hyperconjugations is there or not? For that you must have to see this video of hyperconjugations. तो अभी इसमें दिखते हैं कि किसमें ज्यादा hyperconjugations है. तो by default it has a 9 alpha hydrogen. It acquired a 6 alpha hydrogen. It acquired a 3 alpha hydrogen. So I can say this is a more stable one. The number 1, this is 2, this is 3, and this is a fourth one. This is third one, and this is a fourth one because इसमें ये नहीं होता. This concept is also explained by this inductive effect. I told you that containing the plus charge, to decrease the plus charge, to decrease the charge, increase a stability. This is very important for us. To decrease the stability or that group we required a I plus or it is I plus. We require I plus or M plus, but it is I plus. It is also I plus, but there are two I plus group. So the decrease in positive charge is very high. यहाँ पे पॉजिटिव चार्ज कम हो जाएगा, यहाँ पे इससे भी पॉजिटिव चार्ज कम हो जाएगा. मैंने बताया कि चार्ज डिक्रीज होगा तो स्टेबिलिटी इंक्रीज होगी. इसलिए 1, 2 and 3 स्ट्रक्चर, or simply we can say a tertiary carbocation is more stable than secondary, then primary, then CH3 plus. Okay, so this is one of the concept. Let us go ahead. Now these are the two structure, or we have to decide which structure is more stable. So here I can say that both the structure have what we can say, both the structure have a resonance effect. Okay, I have to write array high. I have to write array high. There is no any resonance. Sorry, there is no aromaticity. There is no aromaticity. In case of resonance, yes, here it is resonance. In case of resonance, here also it is resonance. But in case of this resonance, and in case of this resonance, due to resonance, break aromaticity of benzene. Aromaticity of benzene. So we can say that यहाँ पे एरोमेटिसिटी ब्रेक होती है और यहाँ पे एरोमेटिसिटी का कुछ कॉन्सेप्ट आता ही नहीं है. सो बोथ कंटेनिंग द रेजोनेंस, बट ये ज्यादा स्टेबल होगा क्योंकि इसमें रेजोनेंस के बावजूद और ड्यू टू दैट देयर इज डिक्रीज इन एरोमेटिसिटी. ओके, so here this is more stable. Let us go ahead, arrange the following in stability order. Now we have this two structure. So if we say here, then in this case all that is we write array high. It is also at here array high. In case of array high, there is no aromaticity. There is no aromaticity. It has resonance. It has resonance, but it have a resonance trend is very long, double single, and plus charge. And in case of here, only a small resonance. So there is intensity of resonance is very high. Double single is a long, or we can say increase resonating structure. So we can say this is a more stable and this is a less stable. Let us go ahead. This is known as a benzylic carbocation. Benzylic carbocation. This is known as a allylic carbocation. Let us go ahead. Now these are the three structure. So in case of this is stabilized array high. This is also array high. This is also an array high. So in case of array high, this is not stabilized by aromaticity. This is not stabilized by aromaticity, and this is also not stabilized by aromaticity. It has no resonance. It has resonance. It has resonance. So that is not resonance. So by default, it is less stable. It acquired the third number. It have resonance. It have resonance. Both have the resonance. तो हमें ये दिखना चाहिए कि किसमें लंबी ट्रेन चलती है. अगर हमें इसमें दिखते हैं तो इसमें डबल सिंगल प्लस. So in that case, it is more stable, or it has a long resonance. In case of this is double single plus, only small resonance. तो इसमें रेजोनेंस ज्यादा है, तो दिस इज फर्स्ट, दिस इज सेकेंड. ऑलवेज हमें अरे हाई में एरोमेटिसिटी देखनी है, रेजोनेंस देखना है. अगर दोनों में से एरोमेटिसिटी सेम आती है देन वी हैव टू से विच इज मोर एरोमेटिक. रेजोनेंस सेम आता है तो जिसमें ज्यादा रेजोनेंस है. हाइपर कंजुगेशन सेम आता है तो किसमें हाइपर कंजुगेटिंग स्ट्रक्चर ज्यादा है वो दिखना है. लेट अस गो अहेड. Identify the stable carbocation. So identify the stable carbocation in case of array high. Here also array high. Here also array high. So cyclic structure है ही नहीं, और we can easily conclude that there is no aromaticity, there is no aromaticity, there is no aromaticity, there is no resonance, there is no resonance, there is no resonance. इसमें हाइपर कंजुगेशन है, इसमें हाइपर कंजुगेशन है, इसमें हाइपर कंजुगेशन है. तो इसमें कितने अल्फा हाइड्रोजन है? ये दो और ये तीन. 3 + 2 5 + 2 7 अल्फा हाइड्रोजन. इसमें कितने अल्फा हाइड्रोजन है? ये एक, ये दो, तो 3 × अल्फा हाइड्रोजन. इसमें कितने अल्फा हाइड्रोजन है? इसमें 2 अल्फा हाइड्रोजन है. कौन से वाले? नहीं सॉरी, 1 अल्फा हाइड्रोजन. दिस. तो सभी में हाइपर कंजुगेशंस है, पर किसमें ज्यादा हाइपर कंजुगेशंस इफेक्ट है? तो वी कैन से इट हैज अ मोर हाइपर कंजुगेटिंग स्ट्रक्चर देन दिस वन एंड दिस वन. सो दिस इज मोर स्टेबल स्ट्रक्चर, मोर स्टेबल कार्बोकैटायन. चलो इसमें दिखते हैं. तो दिस इज ऑल्सो अरे हाई, इट हैज ऑल्सो अरे हाई. सो लेट अस कम टू द कंक्लूजन. एरोमेटिसिटी नहीं है, इसमें रेजोनेंस नहीं है. डियर स्टूडेंट, इसमें रेजोनेंस है. दिस इज नॉट टाइम टू एक्सप्लेन द रेजोनेंस, बट आपको उसके लिए मेरा रेजोनेंस पार्ट 1 का वीडियो दिखना ही चाहिए. तो इसमें रेजोनेंस है, बाय डिफॉल्ट इसमें रेजोनेंस है, तो ये विन हो जाएगा. लेट अस गो अहेड. नाउ इन केस ऑफ दिस अरे हाई, वी राइट अरे हाई. दिस इज ऑल्सो अरे हाई. So again we have to do, there is no aromaticity, here also not aromaticity, here no resonance, here also no resonance, here here resonance is there, resonance is there. So by default it is going to be win. So how it has resonance? This is known as a 2-atom resonance. I explained that concept in my video of resonance part 1. Please see that, your concept will improve. So identify the stable carbocations. Again I will write here array high. Here also array high. So first I check between these two we have to do, and after that these two. There is no aromaticity, there is no aromaticity, there is no resonance. Yes, there is resonance, a double single plus. So it is more stable. Very simple. The same structure we have discussed in a last slide, in the initial part of this video. So this is more stable and this is less stable, because there is both are stabilized by hyperconjugations. In the case of this one, again we have to write array high. This is array high. This is array high. So here again we have to do the same thing. It is not stabilized by aromaticity, not stabilized by the aromaticity, it is not stabilized by the resonance, it is not stabilized by the resonance. Here it has a hyperconjugation. Yes, it is have also an hyperconjugations. So किसमें ज्यादा hyperconjugating structure होगी? तो इसमें 3 अल्फा हाइड्रोजन है. देखो ये वाले, इसमें 2 अल्फा हाइड्रोजन्स है. तो दिस इज मोर स्टेबल. वेरी सिंपल. In case of this array high or in case of this array high, there is no aromaticity, there is no aromaticity. Both the structure contain the resonance, but in this case this is our functional group and this is our functional group. So in this case this is M plus and this is M minus. Always M प्लस ग्रुप विल इम्प्रूव द स्टेबिलिटी। तो इसमें हम दिखा देंगे कि ये इस तरह का है तो इलेक्ट्रॉन देने वाला, और ये इस तरह का है इलेक्ट्रॉन लेने वाला। तो दिस इज गोइंग टू बी वेरी स्टेबल कार्बोकेटाइन। आइडेंटिफाइड द मोस्ट स्टेबल एंड अनस्टेबल कार्बोकेटाइन। देखो ये सब में हमें, अभी मैं ये लिखूंगा नहीं, अरे चलो मैं लिख देता हूं, अरे हाय। तो ये सब में एरोमेटिसिटी तो नहीं है, नहीं है मीन्स रेजोनेंस ड्यू टू कार्बोकेटाइन नहीं है। बेंजीन तो रेजोनेंस ही है, एरोमेटिक ही है। नाउ व्हाट अबाउट दिस रेजोनेंस? सभी में सेम रेजोनेंस है, देखो इतना सब में है, सब में रेजोनेंस तो है ही, और ट्रेन भी सेम है। नाउ वी हैव टू फाइंड विच व्हाट इज द इफेक्ट ऑफ दिस ग्रुप। इसमें ये M प्लस ग्रुप है और इसमें ये M माइनस ग्रुप है। मैंने बताया कि प्लस वाला प्लस से स्टेबलाइज होगा, तो दिस इज मोर स्टेबल देन दिस वन, बिकॉज ये उसको स्टेबल, कम स्टेबल करेगा, क्योंकि इट विथड्रॉ द इलेक्ट्रॉन, इंक्रीज चार्ज, इंक्रीज चार्ज, डिक्रीज स्टेबिलिटी। यहां पे ये इलेक्ट्रॉन देने वाला ग्रुप है, तो डिक्रीज पॉजिटिव चार्ज, then decrease stability. Now this identify the most stable and unstable carbocation. देखो ये दोनों ग्रुप है, इसमें ये M, the concept is very similar. I will explain only this one. ये M minus, this is also M minus, both are going to be unstable. तो इसमें ज्यादा स्ट्रॉन्ग M माइनस कौन है? तो दिस मोर स्ट्रॉन्ग M माइनस ग्रुप और लेस, तो इसमें पॉजिटिव चार्ज ज्यादा हो जाएगा, इंक्रीज चार्ज, तो उसमें स्टेबिलिटी क्या हो जाएगी? कम। सो इट इज मोर स्टेबल। लेट अस कम हियर, दिस इज आल्सो, देखो इसमें भी सेम है, दिस कॉन्सेप्ट इज दिस ग्रुप एंड दिस ग्रुप। इसमें ये M प्लस है और इसमें ये I प्लस है। डियर स्टूडेंट, how to remember M plus and how to remember I minus, for that please see this video of inductive effect and mesmeric effect. Always inductive effect है ये, और ये रेजोनेंस इफेक्ट है। तो अरे अकॉर्डिंग टू अरे हाई किसको हमें प्रेफरेंस देना है? रेजोनेंस को। तो ये ज्यादा स्टेबल हो जाएगा क्योंकि ये रेजोनेंस से स्टेबलाइज होता है। ये किससे स्टेबलाइज होता है? इंडक्टिव इफेक्ट से। तो वो that gives the immense effect. Identify the most stable and unstable carbocation. Again we have to write, there is no aromaticity, are high, are high, are high. There is no aromaticity, there is also not aromaticity. In case of there is no resonance, then it is third party. There is no resonance, so we cannot say that can also be a third party. Yes, there is resonance, so I can say this is a first rank, it is stabilized by the resonance. Now we have to check the hyperconjugating structure. So it has 2 alpha hydrogen, 4 alpha hydrogen, it has also 4 alpha hydrogen, it has a 4 alpha hydrogen total. So both have hyperconjugations, but both have 4 alpha hydrogen. It has also 4 alpha hydrogen. Now what? Now this inductive effect will come into the market. So here this carbon is plus sp3 hybridization, so this is I plus, and this is sp2, so this is I minus. So I can say that this is a more stabilized, इसमें plus effect है, this is second number. Now this is a third party, this is not in resonance. So in that way we can give this priority. Let us go ahead. Now what about this? If you see and if you know the concept of aromaticity and anti-aromaticity, this structure is aromatic and this structure is an anti-aromatic. The aromatic ये most stable compound and anti-aromatic is most unstable compound. Now it has some concept. What is that concept? This is a highly stable carbocation, and how, that I will tell you. I will upload one video on a angle strain. According to the angle strain, 3 member rings are unstable. तो यहाँ पे क्या होगा कि जो sp3 ऑर्बिटल है ना वो बैंड फॉर्म में होगी. So this is a special type of resonance of band orbital with a vacant orbital. Band orbital with a vacant p orbital. Now what is vacant p orbital और ये कहाँ से आई? Then vacant p orbital is, this is a vacant p orbital. I can see. तो ये दिस कॉन्सेप्ट इज, ये बैंड ऑर्बिटल की स्टेबिलिटी के लिए ये स्पेशल रेजोनेंस होता है. ये हाईली अनस्टेबल होगा. दिस इज एक्वायर्ड द फर्स्ट रैंक, दिस इज एक्वायर्ड सेकंड रैंक, दिस इज एक्वायर्ड अ थर्ड रैंक. सो दिस इज अब, क्योंकि इसमें क्या होता है कि बैंड ऑर्बिटल्स का वैकेंट ऑर्बिटल से रेजोनेंस होता है. सो अगर हम कहीं जगह पे व्हीकल में जा रहे हैं और हमें हमारी सीट रिजर्व नहीं हुई तो हम स्टैंडिंग पोजीशंस में जाएंगे. अगर थोड़ी देर के लिए भी कोई बंदा खड़ा होकर अपनी सीट्स में से दूसरी जगह पे जाएगा और दैट मूव्स फॉर द वॉशरूम, इमीडिएटली वी सिट ऑन दैट वो बंदे की सीट पे हम बैठ जाएंगे. तो ये क्या है कि बंदे को सीट्स रिजर्व नहीं मिली और उसके साथ वो बैठ जाएगा तो उसको बहुत ही महसूस आराम मिलेगा, उसको इमेंस प्लेजर मिलेगा. तो ऐसा इस केस में कार्बोकैटायन में होता है. सो दिस इज मोर स्टेबल. उसको बोलते हैं साइक्लोप्रोपाइल मिथाइल कार्बोकैटायन. दिस इज नोन एज अ साइक्लोप्रोपाइल मिथाइल carbocation. This is very intense stable carbocation. इसमें से मोस्ट अनस्टेबल कार्बोकैटायन फाइंड करने हैं. This is a unstable carbocation, this is also unstable carbocation, this is also unstable carbocation. उसकी अनस्टेबिलिटी का वजूद क्या है? So here I have explained you according to CD-ON, or I can say that it acquired this group. There is directly, there is no aromaticity, resonance, inductive, hyperconjugations. ये है ही नहीं इसमें. We have to see about the inductive effect. So in case of inductive effect, this is I minus group. In case of this also, this has also a I minus group. ये और इसमें डिफरेंस है. ये मोस्ट स्टेबल है, ये अनस्टेबल है. Now in case of this is known as a breeze head carbon. In case of breeze head carbon, this acquired the sp2 geometry after formations of the carbocation. अगर कार्बोकैटायन होगा तो sp2 geometry हो जाएगी. And sp2 geometry is a planar है. ये क्या है? planar. तो प्लानर में ये ब्रिज बन ही नहीं पाएगा, इसीलिए ये अनस्टेबल पोजीशंस है. तो ये 3 अनस्टेबल कार्बोकैटायन बोलते हैं. इसमें से महा अनस्टेबल हम इसको बताएंगे. दिस इज अ महा अनस्टेबल कार्बोकैटायन. लेट अस गो. दिस इज डिफरेंस बिटवीन कार्बेनियम आयंस एंड कार्बोनियम आयंस. दिस एग्जांपल ऑफ द कार्बेनियम आयन इज CH3+ and this is CH5+. This is carbonium ion. Number of carbon bonds to the carbon is 3. वो तो दिखता ही है. इलेक्ट्रॉन इन द आउटर शेल 6, वो भी दिखता है. sp3 और sp2 hybridization, so there is one p orbital vacant, empty p orbitals. At the last is it is electron deficient. It's required the electron because it has 6 electrons. So to complete the octet, it required the electron. Number of bonds of the carbon is 5. दिखता है वो भी, देखो इस एग्जांपल से पता चल जाएगा. इलेक्ट्रॉन द आउटर मोस्ट सेल इज 8. इसमें 8 इलेक्ट्रॉन्स है क्योंकि वो इस तरह से कोवेलेंट बॉन्ड तो ये चारों ही बनाएंगे. दैट इज जस्ट टू बाइंड बाय द इलेक्ट्रोस्टैटिक फोर्स. नाउ MTP orbital, there is no MTP orbital. Electron deficiency, there is no electron deficiency because it is already complete the octet. So this is a little bit difference between carbenium ions and a carbonium ions. So this is a sequence I want to share with you. It is stabilized by bent orbital with a vacant orbitals. उसको सीट्स नहीं मिली है, उस बैंड पोजीशंस में है, उसको थोड़ी देर भी जगह मिल जाएगी तो उसको बहुत ही अच्छा महसूस होगा. ये एरोमेटिसिटी से स्टेबलाइज होता है. एंड एरोमेटिसिटी अकॉर्डिंग टू अरे हाई इज वेरी इंपॉर्टेंट फॉर अस. ये दो रेजोनेंस से स्टेबलाइज होते हैं. ये और अप टू दिस ये हाइपर कंजुगेशन एंड इंडक्टिव इफेक्ट से स्टेबलाइज होते हैं. मैंने वो भी बताया कि प्लस को स्टेबल करने के लिए प्लस इफेक्ट चाहिए, यहाँ पे भी प्लस को स्टेबल करने के लिए प्लस इफेक्ट चाहिए. दिस आर अनस्टेबल कार्बोकेटायन और दिस इज महा अनस्टेबल. तो इसमें हम लिखेंगे ये हमारा महा अनस्टेबल, इसको यहाँ पे लिख देते हैं महा अनस्टेबल कार्बोकेटायन. ठीक है, दिस इज महा स्टेबल कार्बोकेटायन. तो बच्चों ये थोड़ा बहुत ही सीक्वेंस आपको बहुत ही इंपॉर्टेंट यूज होगी. यहां तक सभी कॉन्सेप्ट इज वेरी गोइंग टू बी, ये जियोमेट्री में फेल हो जाता है, इज गोइंग टू बी वेरी क्लियर. अरे हाई को याद रख दो. और ये क्या है कि बस में हमको ट्रेन में जगह नहीं मिली है और जगह मिल जाती है थोड़ी देर के लिए तो बहुत ही अच्छा महसूस होता है और ये स्पेशियस रेजोनेंस स्टेबिलिटी हमको मिलता है. तो इसका ऑप्शंस ये है और उसका आंसर आपको मेरे को भेजना है. ठीक है, यहाँ पे फिर देखो उसको बोलते हैं, आई वांट टू डिस्कस विथ यू दैट आल्सो. दिस इज नॉन एज अ बेंजाइलिक कार्बोकेटायन. उसको क्या बोलते हैं? बेंजाइलिक. उसको बोलते हैं अलाइलिक कार्बोकेटायन. उसको टर्शियरी, उसको सेकेंडरी, उसको प्राइमरी, उसको मिथाइल. और उसको मैंने बताया कि साइक्लोप्रोपाइल मिथाइल कार्बोकेटायन. क्या बोलते हैं? साइक्लोप्रोपाइल मिथाइल कार्बोकेटायन. उसको बोलते हैं साइक्लो ऑक्टाट्राइनाइल कार्बोकेटायन. देखो इसमें फिर ये ऐसा हो सकता है कि ये जो है, तो देन वी विल टेक दिस एग्जांपल ऑफ महा स्टेबल कार्बोकेटायन. तो इसमें क्या होगा, इफ वी सी हियर, तो उसमें क्या होगा कि देखो हमारे पास ये एक है, तो उसकी स्टेबिलिटी इसकी स्टेबिलिटी से ज्यादा ही होगी क्योंकि ये जो बंदा है जिसको सीट नहीं मिली उसको यहाँ पे भी मिल जाएगी, यहाँ पे भी मिल जाएगी. सो देयर आर टू इफेक्ट. दिस इफेक्ट इज गोइंग टू बी इंक्रीज देन स्टेबिलिटी इज आल्सो इंक्रीज. यहाँ पे देख लेते हैं, चलो यहाँ पे ये इससे भी ज्यादा होगा क्योंकि उसके पास 3 पोजीशंस है, उसको सीट नहीं मिली और उसके पास 3 बंदे हैं, वो यहाँ से चले गए हैं और कहीं पे घूमने गए हैं, तो वो उसकी जगह पे बैठ के बहुत ही अच्छा महसूस कर पाएगा. इसी तरह सेम ऐसा भी हो सकता है कि ओके दैट कॉन्सेप्ट इज इट्स इनफ, रिमेनिंग यू अप्लाई दिस हाइपरकंजुगेशंस एंड ऑल दिस थिंग. तो ये एक एग्जाम्पल और द क्वेश्चन मैंने दिया है, रिप्लाई इन कमेंट बॉक्स. मैं आशा करता हूं कि आप लोग ये वीडियो देख के उसका आंसर मेरे को भेजोगे. थैंक यू. एंड if you enjoy a lecture or the concept of the carbocation, then please write in comment box. If you need any extra video for such a type, you can also write in the comment box. So I make this video for to improve this concept of organic chemistry. Thank you. Thanks a lot.